Hello, in this lecture, I try to clarify the interval estimation of population mean, how to calculate the population mean, and how to calculate the standard deviation of the population, and also the interval estimation of the population mean will be considered in this lecture. Here, I have divided this lecture into two parts. This is the first part, and and I will give the lecture, the remaining part in the second, the remaining lecture in the second part. So let's begin. So here is a problem. A number of wheat packet per truck for the population of 10 trucks is given in the following table. Here is the table, and you can find that there is 10 trucks. That is T1, T2, T3, T4, T5, and in this way T10. And the number per truck, that is T1 has 22 wheat packets, and T2 has 25 wheat packets, and in this way T10 has 24 wheat packets. Okay, so this is the information. On that basis of this information, we will calculate the population mean and the population standard deviation, and how it can be calculated, and look at this slide. So this is the method through which we can calculate the population mean and the population standard deviation. And here is the first column represents the trucks, represent the trucks T1 to T10, and the second column represents the packet, wheat packet per truck, as mentioned here, that T1 truck has 20 packets, T2 has 25 packets, and third column represents the difference between the wheat packet per truck and the mean of the wheat packets, wheat packets in total 10 tracks. So mu is the mean, and this column is represent the third column. So and the fourth column represents the square of the difference between the wheat packet per truck and the mean, the average wheat packet per truck. So now look, the mean of the mean. How can we calculate the mean? So here you can find the 20 wheat packets, 20, 25, 23, 24. In this way, there are 10 rows. 10 rows. We add all these rows and divide it by 10, and we get the mean, the average wheat packet per truck. So that this is the 25. This is 25. Now, now this is xi. It means 20, and mu is 25. So this the minus 5 is here, and this represents the 25. Xi 25, mu is 25. So 0 is here. So xi is 30 and mu is 25. So 5 is here. So in this way, so xi is 15 and mu is 25. So minus 10 is there, and xi is 24 and mu is 25, so minus 1 is there. So the xi minus mu values are this. Okay, this is the square of these values and square of these values. So now the standard deviation has a formula, and root of x minus mu whole square divided by the number of population. Suppose here is 10. So 10. So it is n. So 306 is the sum of this column, and divided by 10. And after getting root, we have a value that is 5.5317. Okay, this is the standard deviation. So population mean and population mean is 25, and standard deviation of 5.5317, depending on this table. Okay, so now this column represents the different possible random samples, simple random samples, depending on the previous table, depending on this table, this is the table, depending on this table 1, depending on this table. Okay, so previous table. So this is the sample that is two track, two sample, two sample. We have taken two sample, that is the T1 T2, and we get the sample mean 22.5. How? Look at this. Look at 20 plus 25 divided by the 2 is nothing but the 22.5. And T1 and here is T1 T3. So it is a sample. It is a sample T1 T3. 20 plus 30 equal to 50 divided by 2 is the mean, sample mean. So 25 is here. And T1 T4 in this way, T1 T4 T1 20, T4 is 24. So 24 divided by 2 equal to 22. So 22 is here. So in this way we get the sample mean. Sample mean, the number of samples. So we have um, we have we have sample mean. Okay. So probability of getting T1 T2, probability of getting T1 T2, that is the sample mean. Probability of getting sample mean T1 of T1 T2 is 1 by 4 5, because total number is here 4 5. The probability of getting T1 T2 is 1 by 4 5. Probability of getting sample mean 22.5 is 1 by 4 5. Probability of getting sample mean 25 is 1.45. In this, all the values, sample mean has the probability of probability is, and probability is 1.4, 1 by 4 5, 1 by 4 5. Now on this basis of the table, you can find this is an arrangement of the previous table. So sample mean, you can find the sample mean here. The sample mean is 22.5, 25 sample mean, because here 22.5. Look at this table. Look at 22.5, 22.5, 1, 22.5, 2, 22.53, 22.54. Okay, so we have to add this probabilities: 1.45, 1.4, 1 by 45 plus 1 by 45 plus 1 by 45 plus 1 by 45 is equal to 0.089. So here again 25, here is 25, 1, 2, 3, 4, 5. 525 25 are there. So probability is the summation of 5 1 by 4 5. So here look at this 1 2 3 4 5, and adding we get 0.11. So in this way the sample mean with sample mean with the probabilities we have. In this table we have sample mean with the probabilities. Okay. So so now this is the figure. Depending on this table, and along the vertical axis we measure the probability of the sample mean So here it represents 17.5. You can find that 17.5 equal to 0.045. So 17.5 and 0.045. This is this amount of probability. 38, 17.5 mean. And in this way 25 mean, that is the 25 is 0.111 probability. So 0.11 probability this amount. So in this way we present the sample means and corresponding probabilities in a graphical way. So this is a simply a probability distribution. Okay, this is simply a probability distribution that shows the probabilities associated with all possible values of the sample mean. Okay, this probability distribution is the sampling distribution of x bar. This is nothing but the sampling distribution of x bar. Okay, now the mean of all possible values, possible x bar is as follows. This is the mean, population mean, and standard deviation is this. Standard deviation is, this is the formula you can find. Sorry, just a moment. This is, now this is the mean, population mean. You can find the population mean here, summation xi. It is the sample mean. Sample mean is the expected mean. Expected mean. Sample mean is the expected mean. Look at this. These are the mean. These are the means. So here, here, mm, this mean has different probability. This mean has another probability. So, so the probabilities probability differs depending on the sample mean. So we have to find out the expected expected mean. So expected mean is nothing but the summation divided by summation of this column divided by divided by divided by n. Now n divided by n. Okay, so divided by n. So here summation xi summation xi by n, summation xi by n, you can find here summation xi by n is the sample mean. Here is the sample mean 25, xi by 25. How it can be looked at? Look at this. This is the sample mean 25 is equal to with the is equal to 25 is equal to 25 mean is the population mean is 25. So ultimately we adding ultimately we adding this summation xi summation xi by n equal to 25. It is also the population. Okay, it is also the population mean. Now standard deviation, here you can find. Now look at the standard deviation. How can we get the standard deviation? So this is the standard deviation sigma x bar is the standard deviation of sample mean of the sample standard deviation. So it has the formula that is the capital N minus small n by divided by the capital N minus 1 and multiplied with sigma by root n. Sigma is the standard deviation of the population and this is the sample, this is the number of samples. The number of sample is 2, total number is population is 10. So 10 minus 2 and 10 minus 1 and standard deviation of 5.532. We have to get it from here. This is this one. Okay, this one. Now after some simple steps we get the standard deviation of sample of the sample is 3.694. Okay, 3.694. Now what is the central limit? Now what is the central limit theory? Look, in selecting simple random samples of size n from a population with a mean mu and standard deviation sigma, the sampling distribution of x bar approaches a normal probability distribution with the mean mu and standard deviation sigma by root n. As the sample size becomes large, it means that what is the central limit theory? Central limit theorem, the central limit theorem is the key to identify the form of sampling distribution of X bar. Whenever the population distribution is unknown, population distribution is unknown. When the population distribution unknown, central limit theorem has an important role. And depending on the central limit theorem, we can have the probability distribution of the sample mean. So this is the role of the central theorem. Okay, in selecting simple random samples of size n from a population with mean mu and standard deviation sigma, the sampling distribution of X bar approaches a normal probability distribution with mean mu and standard deviation sigma by root n. This is the central limit. Now, here is the problem. Here is the problem. If we solve it, then we can clarify our concept. Okay. So find out the probability of selecting a simple random sample with x bar between 20 and 30, considering the problem one. Our problem, I have mentioned the problem in my first slide. That is there is 10 traps. That is the population is 10, and here we have to find out the probability of selecting a simple random sample with x bar 20 and 30. Now the solution. Look, since the sampling distribution of x bar can be approximated by a normal probability distribution, we can use standard normal probability distribution to answer these questions. Standard normal probability distribution. Okay. So now we have to find out the z value. What is the z values? Z values, suppose z values is these values. Here z values, here is z values, here is z values, here is z values, so z values. So z equal to, depending on 20, where at x bar is 20, at x bar 20. So z value is equal to x bar minus mu sigma x bar. Okay, sigma x bar. So 20 minus 25 divided by the 3.694 is equal to minus 1.35. This is the z value at x bar. At x bar. Okay, x bar is 20. Then this midpoint is 25 and 20 is suppose this, and here the z value is minus 1.35. And at 20, at 25, here it is 20, it should be 30. Okay, it should be 30. It should be 30. It should be 30. At x bar 30, z equal to 30 minus 25 divided by the 3.694 is equal to 1.25. So this is the 1.25. The z value at x bar equal to 30. And this is the z value. That value is minus 1.35 at x bar equal to 20. Okay, at x bar equal to 20. So, looking up the z equal to 1.35 in the table of areas for the standard normal probability distribution shows an area of 0.4115 between 20 and 25. This is 20, this is 25, this is suppose 25, this is suppose 25. So this 25 and 20, the area is 0.4115. This area. Look at my cursor. This is pointed. This area. Okay, this area represents 0.4115. We can get this value from the standard normal probability distribution table. Okay, and and also the probability or the area between 25 and 30 is also 25 and 30. This area, okay, this area is also 0.4115. We can get it from the standard normal probability distribution table. So, as far as our problem is concerned, so the value of x between 20 and 30, that is this area, this total area is nothing but the add of this area and this area. Okay, so 0.4115 plus 0.4115 equal to 0.4823. So 0.823. 0.823 is the total area. So so this is the this is the problem, and here I in this lecture, and this is the lecture of it is a part one lecture. So in this lecture I have tried to clarify how to calculate the population mean and population standard deviation, and how to calculate the sample mean and the sampling and and the standard deviation of the sample and the standard deviation of sample. And here is a problem, and here is a problem, and the problem shows that the mean, suppose the simple random sample with x value x between 20 and 30. 20 and 30, that is 20 and 30, that it means that a track bearing 20 wheat packets and a track bearing 30 wheat packets. What is the probability? What is the probability? So here in this lecture, I try to solve a practical problem. So I hope you have enjoyed this lecture and and enriched your knowledge thereby.